You have two variable equations with an example. So let's just write out 6x plus 3y is equal to 6 and 2x plus 3y is equal to 2. So as we saw in our previous video, we can subtract stuff from both sides of the equation as long as we change both sides the same way. But in two variable and even higher systems of equations, you can subtract equations from each other. Like you can literally subtract this whole entire equation on the bottom from the one on the top. So for example, I'll subtract the two and we get 4x, because 6x minus 2x plus 0 is equal to 4. Or then it's a single variable equation which we know how to solve. You just divide by 4 on both sides, and then you can get x is equal to 1. Then if you plug it in to the first one, so 6 times 1 plus 3y is equal to 6. Subtract 6 from both sides, you get 3y is equal to 0. Divide by 3, so then y is equal to 0. You can see how we solved our system of equations pretty easily from just subtracting the two equations from each other. Such it tells us the point, where you have to subtract the two variable equations from each other effectively such that one of the variables gets cancelled out, where then you just get a one variable case here, and then you can plug it back in to get another one variable case. So you saw how we simplified a two variable equation all the way down to two nice one variable equations. That's essentially what we're going to be trying to do. So over here, let me just write out a new one. So 3x plus 4y is equal to 10, and 6x plus 2y is equal to 2. Now, you might be thinking here, if I subtract two equations from each other, I still have two variables. So what should I do? Well, normally to do this, you have to try to choose which variable you want to eliminate. For me, I always try to eliminate y. So let's try to eliminate y. So we can see that there's 4y in the top one and 2y in the bottom one. So then what we can do is we can multiply by 2 on the bottom equation. So you can multiply by 2 on both sides of the bottom equation. So then you get 2 times 6x plus 2y is equal to 2 times 2, which is 4. So then you have 12x plus 4y is equal to 4. And you have 3x plus 4y is equal to 10. So now it's pretty easy from here to just subtract the equations from each other. So don't mix up the signs always. So 12x minus 3x, so that's 9x. And then 4y minus 4y is 0, so that's the point, we eliminated it. And 4 minus 10 is minus 6. Then what you can do is you can divide by 9 on both sides to get x is equal to minus 6 over 9, which from our fractions video, you learned that this can simplify down to 2 minus 2 over 3. Then you can plug this value of x back in to our original equation, so 3 times minus 2 over 3 plus 4y is equal to 10. So this is like minus 6 is plus 4y is equal to 10. So you can add 6 to both sides. So then from that, you get 4y is equal to 16. So then y is equal to 4 by just dividing 4 on both sides. Giving our answer, we always write as x comma y is equal to minus 2 over 3 comma 4. Nice and easy. Now that we've pretty much learned the goal in trying to find these, let's learn about a special case which could come up. It'll be 2x plus 2y is equal to 4, and x plus y is equal to 4. Not 4, 2. So, we would start with our normal strategy, try to eliminate y. So then we can multiply by 2 on both sides of the bottom one, so we get 2x plus 2y is equal to 4. But wait, isn't this the same? What? It's the same equation. So then what can we do? Well, since there are two variables and one equation which comes out of this, there's really an infinite amount of solutions. There are so many solutions which could come from this. since you can try any x and then you can fix any y value to solve it. So in this case, there's going to be an infinite amount of solutions, x and y. Now, in the other case, where let's say it was x plus y is equal to, let's say x plus y was equal to 3. Then when we do the same multiply by 2 on both sides, we get 2x plus 2y is equal to 6. And then you also have 2x plus 2y was equal to 4. So now, how can these two equations equal two different things? Isn't that interesting? Well, in the case they're equaling to different things, then there are no solutions. Since, how can they be equal to two different things at the same time? So pretty much, these two special cases, we'll learn a more visual approach to this when we learn in our next video about the graphing method to solve these problems. So thank you for watching the video, and stay tuned for the next one. I hope to see you then.